Hello, everyone. Thank you very much for joining us. I'm very happy to be here today with a very special guest. We have Alina Yurenko, who will teach us a lot of things about GraalVM. Alina, thank you very much for joining us.
Thank you so much for having me. Hi.
So today we're going to learn a lot of stuff. So I hope you have already. I see already people joining. So the number is growing there. Friends, just to remind you, you have a live chat there, so you can ask the questions in the live chat. We will be actually Alina will be more than happy to answer you. And if you are not joining us live, if you see the recorded session, then remember that you can put your comments in the comment section. And of course, please do follow us both on Twitter and LinkedIn and whatever social media you find us out there. With that being said, so Alina, I will let you talk about introduce us to GraalVM, please. Tell us what's so fashion about GraalVM today.
Cool. I will tell you in a second. I was just trying to open myself the links, the comments on YouTube, and somehow I cannot make it work from my phone. So I will trust you to let me know if there are comments or
Sure.
questions. Okay. Cool. So yeah, let's talk about GraalVM. My name is Alina. I'm a developer advocate for GraalVM at Oracle Labs. I have been working on this team and on GraalVM for the past almost 6 years now. So as you can imagine, I've been doing this a lot, like telling people about GraalVM and what it is. So I was thinking maybe today we can make this video a bit more conversational. I will show some demos because you cannot talk about GraalVM and not show demos. But overall, I was thinking maybe we can make it more conversational. I will tell you some recent cool updates from our community, some of the big things we are working on. And maybe I will skip this, big introduction to GraalVM. Maybe I will make like a smaller one for your subscribers. Maybe they know GraalVM slightly less. But overall, I will maybe jump into those more like recent news and community topics. Okay, let me pull my little agenda. So I did prepare some things that I want to talk about, but also I'm very open to questions. So if you have any questions, just let me know and we will adjust as we go. Okay, let me see where I have it here. I can just share here where we are talking, right?
You can, sure.
Oh, host disabled participant screen sharing. Can you give me the permissions?
Yeah, you have them.
Okay, let me try again. Cool. Desktop 2. Okay, let's go. You're supposed to see it, right? Let me just move this here. You see my screen? All good, right?
Whoa, we have 12 points on the list. I'm really
Yeah,
good to
I'm
see.
sorry. I thought I will not have things to talk about. And then I started writing down the things that I want to talk about, and it appeared like way too many. So let's see if we can, go through most of them. We don't have to cover them all. So GraalVM in 5 minutes, maybe less. We've been doing those intro talks for a while, so maybe I don't need to do like a very big intro, but just to kind of sync up and be on the same page. Can I not move this window 1 second? Oh, okay, good now. Yeah, so GraalVM in 5 minutes. There are many things to know about GraalVM, but to boil it down, there are three main parts of it that you need to know, and especially if you're a Java developer. So one is that GraalVM is a JDK. It's just like any other JDK of your choice, Oracle JDK, OpenJDK, etc. And it can do anything that any other JDK can do. And the only thing that we are changing if you're using GraalVM as a JDK is that we are replacing the top tier optimizing compiler. In OpenJDK, that is C2, and in our JDK, that is the GraalJIT. So our own brand new compiler that we wrote ourselves. And you can use it as any other JDK. You just get GraalVM, point your Java home to GraalVM, voila, you're done. You're using the GraalVM JDK. And the reason to do so is because many workloads, and we will see some examples later on in the talk, many workloads will run faster from GraalVM because there are many brand new, highly optimizing additional compile optimizations in GraalVM as a JIT. So it's a better JIT for your Java workloads. That's one big part of the story. And then there is the next big part, and that is native image, and that is ahead of time compilation of Java applications. So what we can also do is we can take a Java application and compile it ahead of time into a native executable, then can run without a JVM at all. So you can just deploy it on a machine that doesn't have a JVM, and it will run completely as a native executable. And the reason to do so would be that it will then start much faster. So it will have faster startup because we will eliminate and kind of shift towards the build step, all that work, that the JVM normally does at runtime. So normally you would need to load your classes, look at them, start interpreting, profiling, compiling, and then eventually you warm up and you get to that good, famous peak performance that we all like so much. So with native image, we offer you a trade-off where you can do all that kind of infrastructure work at build time rather than at runtime, because we believe that many applications are started way more often than they are built. So it kind of makes sense to do all that work once, have your native executable, and then start it very fast every single time when you need it.
So
And
Alina, you tell me that I can use GraalVM without necessarily compiling natively my application. You said
yes,
it's just like a JDK. And would I do that for a reason? Because the majority I know they associate GraalVM with native compilation.
yes, because native image is so, shiny and cool and revolutionary. So obviously, we get a lot of questions and a lot of love for native image. But you can totally use GraalVM as JIT. And one of the examples here, so bullet point number 9, where it says GraalVM and CERN, they actually using GraalVM, or at least benchmarked GraalVM to run Apache Spark workloads. And then for Spark, I think, I don't remember the exact numbers, but it was substantially faster to run the workloads on GraalVM. And we will take a look at the actual numbers when we get there. But overall, just on top of my head, depending on the workload, you can easily expect 10, 15, 20% performance improvement over C2. And, it might not be, the fastest possible optimization you can imagine, but for this simple switch where you are just replacing your JDK with GraalVM JIT, which you can do maybe, I don't know, in 5 minutes, I would say those 10, 15, 20% performance improvement, it's very substantial, especially if you have a high load workload or many nodes, because each of them will contribute to this overall improvement. So I would say this is a very good reason to use it. So yes, definitely we have many users internally and externally that are using GraalVM as a JDK. Cool. Any more questions or comments yet?
So someone actually asks you, when are you going to start your own YouTube channel?
I was expecting that question coming here. I kid you not, because I'm on your YouTube channel. I do have a YouTube, how do I say, profile, but just as a normal human being to watch content on YouTube. But I started thinking that maybe I should also start my YouTube channel. But in the meantime, go and follow GraalVM on YouTube, and we have a lot of cool stuff there as well.
Good.
Okay, so we covered GraalVM as a JDK, so the GraalVM JIT compiler, we covered native image, and the last remaining big part of the puzzle is what we call Polyglot VM, or embedding other languages in Java. And that it means that with GraalVM, you can execute many more languages that are not traditionally Java or JVM languages. So you can execute things like JavaScript, Python, Ruby, etc. And you can definitely just execute plain JavaScript or Python on GraalVM. But where we see a lot of potential and kind of a lot of interest in the community is in embedding those languages in Java applications, because there is a huge ecosystem of Python libraries out there, specifically for data science, machine learning. Obviously, there are a lot of good libraries in JavaScript as well. And quite often there is a need to maybe reach out and use that one particular library. And what if I already have a Java application? So GraalVM gives you a good way to embed those other languages and other libraries in your Java applications, because we will give you fairly easy to work with tooling and a way to do so. What you need to do in that case, you're just pulling in 2 Maven dependencies, and you can immediately say something like, hey, this Python, this snippet of code, this will be Python, please execute it as Python. And we have our own GraalPy runtime that will help you easily embed this Python code in your Java application. And we will also take care of making sure the whole thing runs smoothly and also runs very fast. So GraalVM JIT, GraalVM native image, and those Polyglot capabilities, that is everything that you need to know about GraalVM in more or less 5 minutes. Cool. And I also wanted to talk with you about what we released recently in GraalVM for JDK 22. Let me maybe pull the release blog post so I can show you what I mean. So we release every 6 months on the same schedule as Oracle JDK and OpenJDK being released, and not only on the same schedule, but also on the same day, which is very cool. So for example, on September 17th, we will have the Java 23 release, and also on September 17th, you will have the GraalVM for JDK 23 release. So if you want to have the access to the latest features of both Java and GraalVM, you can definitely have it on the same day with the GraalVM download. But let's look what was new in that last blog post. And let me scroll to one thing that I want to show you. So there were many updates, but I want to mention this specifically, this one. So we have this feature in GraalVM and native image specifically that is called build reports. And that is a tool that kind of assists you as a developer understand better what is happening in your application. So with build reports, which you can generate by passing a flag to native image, you can get a report that looks somewhat like this. And there it will show you details about your application that we discovered as we were building your application. So it will show you code area, image heap. It will also show you software bill of material if you're passing the SBOM flag. And what we added in that last release was also those very cool flame graphs. I don't know about you, but I love flame graphs. Let us know in comments if you also love flame graphs. And this particular one shows you how each of those methods that we see on the flame graph here contributes to the overall execution time. So if you have some suspicions or if you want to explore what is happening in your application and which methods are taking up the most time, you can definitely do so with this cool flame graph or also a histogram if that's your preference. And let me
Can you share us the link for this article? I will put it in the chat.
yeah, I think the easiest would be if you go to medium.com GraalVM, and then there it's pinned as a featured blog post, I believe. Okay, and what else that I want to mention in this blog post? So as always, we are working on improving the developer experience. Every time we want to make sure that you get faster builds, that the builds are using less time, less memory, less resources. And also we keep adding tooling around monitoring such as GFR events, so you can use them in your native application as well. And this is actually the part that I wanted to get to. So you were just asking me about GraalVM as JIT and why would we want to use GraalVM as JIT. And I wanted to show this couple of benchmarks from our actual community members. I have a feeling you actually know Ionat, right?
Oh, of course. Yeah, I mean, it's part of our community in Romania. So,
Exactly.
and
Yeah.
he's a very, I mean, he's an expert in performance in general. We've seen at Vox, Bucharest, and Cluj usually plenty of discussions on performance from Ionut. So, I really enjoy watching his presentation because I always learn something new.
Me too. And yeah, he's actually, as you said, like a very good performance expert. And I like this study that Ionat and Florian has published about performance optimizations and results and benchmark of different compilers. So here you can see GraalVM. We have two editions, GraalVM CE, which is community edition open source, and then Oracle GraalVM, which is an Oracle product, and in comparison with OpenJDK, so effectively the C2 compiler. And I like this one sentence here when they're saying on the wide set of benchmarks. I honestly don't remember, but it was a huge set of benchmarks. And they said that they saw consistently update of improvement of 17% running faster with GraalJIT on ARM and 23% faster on x64. So I would say for this wide set of benchmarks, a wide variety of applications, this is very good to have anywhere between 17 to 23 performance improvement just by switching to GraalVM as a JDK. I think this is really cool, and we are looking forward to new benchmarking numbers that we will have with the upcoming GraalVM for JDK 23 release. Now, GraalVM for JDK 23 is coming soon, as I mentioned in September. I cannot talk about this release much yet because we prefer to keep all the cool stuff for the release so then we can announce it and, you know, like have a nice surprise. But I can tell you that we are definitely working on some very cool features. And in particular, we will have cool updates around performance and security, among other things. So if you're curious about those updates, September 17th, we will have a release stream, we will have a release blog post, release notes, so you can learn all about it and give it a try. Now, with all the talking, I thought maybe I will show you this in action and you will see at some cool apps that you can build with GraalVM. Before I do, I need to make a disclaimer that all speakers are currently on a summer break, so I haven't done this in like 2 months. I mean, like publicly showing something. So if something goes wrong, cut me some slack. Let's see.
Oh, we are seeing code. Nice.
Yes.
I love code for some reason.
Okay, so the first thing that I want to show you is this native Spring AI app. because obviously you cannot do a talk about without using AI these days, right? So this is what all the cool kids are doing. And let me actually run it, and then I will tell you what it does. Oh, I can actually show you first the file size. So this is a Spring Boot application, and this is my native version of it, which in this particular case has the size of 109 megs, more or less, which is not the smallest app in the world, but it contains quite a bit of stuff in it. So we will see in a second, but just keep in mind that this size, like 100 megs, is my complete app, fully packaged and fully ready to be deployed, which I think is pretty good for like substantial Spring stuff that contains quite a bit of things in it. But let's run and let's see what it does. So target travel app, I believe. And it starts in just, let's say, 48 milliseconds, which I think is pretty cool.
Wow.
Yeah, but let's see if it works. I have a feeling I might need to remap the ports. Oh, no, it's good. Okay, so what we see here, it's a travel application. Let's say you want to go on vacation, such as, for example, you told me you should go on vacation, but you don't have any plans yet, right? So maybe we can come up with some plans for you. And this is the travel app. Before we do, I would just want to explain that this very minimalistic UI is because I wrote this front end and all the HTML and CSS myself. It might not look very pretty, but trust me, it looks much better than the very first version of this front end that I wrote. So I would call this already an improvement. So let's say we want to travel, I don't know, let's say to Norway, because this is where I will be traveling for the next conference. And let's say we want to do hiking, and then let's say we are feeling adventurous. And when I click let's go, this will send a call to the OpenAI API through Spring AI and will generate travel recommendations for us. Let's see. So for Norway, hiking and adventurous mood, I recommend visiting the Lofoten Islands. Okay, I don't know if that's any good or not, but kind of sounds good to me. Let's just give it another shot just to make sure that this is not any hard-coded data and it's actually making like generated responses live. I was actually curious because in my API call, I'm saying that this field is a country, but I'm wondering if I pass something else there, if it will work or not. And to be honest, I never tried, but let's give it a try. So let's say I'm passing not a country, but something else. I think the LLM should be smart enough to figure it out. But let's see. And let's say I want to do cocktails this time. And let's see if this even sees, yeah, I think this is still fine. So visiting Palma de Mallorca. Okay, I think this sounds good. And let me show you how this actually works. So as I mentioned, this is a native application, right? We see this before because it was only 100 megs. And it also started so fast where it was in 48 milliseconds. Now, if I kill this app, because we saw it in action already, and if I remove this and maybe show you the app, yeah, so this is my service. Let me just zoom out. That is doing the actual logic of talking to the OpenAI API. And this is just my controller handling those requests. And in my POM XML, I have all the things needed for this. So Spring AI, time leaf, etc. And it just works as a magic really well with native image. I didn't have to do any configuration, nothing tweak manually. I'm just passing a preferred name for the application so that I can just remember it. And this is it. So I built it from scratch, compiled it to native with one command, and it just worked. So this is pretty cool, I think. What do you think?
Yeah, it looks amazing. I mean, I love what I see.
Okay, and I want to show you one more app. Let me maybe first go there, and I will tell you the story. So this one will be native modern Java. Yeah, this one. So the story behind this app is the following. I have this little fork on GitHub. Yeah, this one. So this is a fork, and the original repo is here from Nikolai Parlog.
Ah, Nikolai.
Let us know in
Awesome,
comments
yeah.
if you know and love Nikolai. I'm sure everyone does. Nikolai is such a star and a great friend. So he has this.
Sending hearts to Nikolai. No, please follow Nikolai.
Yeah, so he has this very cool repo that he has built to showcase the latest Java features. This is meant to use all the latest and greatest features of Java and show you how you can actually do it. And what I did, I thought, why not make it native? So for that, I have my little fork over here. And I did some things there, mostly because I was moving stuff between two machines. But to move the app to GraalVM, all I did was I did this. So I added things to README, and the actual migration to GraalVM and native image specifically was just adding this one plugin, which is Native Maven plugin. And this is our official plugin that we built ourselves as a team and we recommend for building native image applications.
So it's almost out of the box, no?
Definitely in this case, out of the box. And I always recommend using this plugin. You don't need it. So you can just run a native image, give it your jar or your classes, and it will build the app itself. But I just prefer doing this from Maven. And also this plugin gives me additional things such as support for testing. I can pull config for libraries that need config using this plugin. So overall, and why am I even showing this in the first place is whenever people ask me, how do I migrate my existing application to GraalVM? I'm always saying the following. So either add this plugin, try building and see if it works. And if not, like what exactly is the issue? Or maybe if you are on a version of a framework that is like newer and supports GraalVM out of the box, then the same plugin is also included under the hood in your framework. So you and I are both fans of Spring. For example, Spring Boot, since version 3.0, it includes native image support out of the box. And it means that when you go to start.spring.io and you add native image as a dependency, it will under the hood include this plugin. And I like it a lot because for me, this is a universal kind of interface to talk to native image and configure things. For example, I want to pass my preferred application name, or if I want to enable preview features, etc., I can always do it here. So for me, it's a nice standard way of working with native image. And all I did to move Nikolai's application to native image was literally just add this plugin, compile it, and see if it works. Now let's actually see it in action. And what this app actually does, this is a GitHub crawler. So you give it a GitHub page and it will go there and it will crawl all the links that it can find on the page. So let's see this one. And I have it compiled to save us time. When we look here, this is my native modern Java. And obviously this is more slim because this is just using standard Java library. It's not pulling any frameworks, etc. So it's fairly slim, but you can also appreciate the size. It's only 37 megabytes. So let's run this. And I will need to give it target native modern Java. So it's a GitHub crawler. So I need to give it some page to crawl. And let's give it this one because I like it a lot. This is one of big projects that we are working on. Let's do this one. And we need to specify our preferred crawl depths, let's say 3. And now let's pray that I haven't abused the GitHub API today and it will still let me crawl. Okay, I think we are good. So it already printed out what are the links that I found on the page, and it's a big project, so it found a lot of links there. But also we can go to a local host and there we will find a server serving us the same kind of information. And you can also appreciate Nikolai's front-end skills because this is—
I mean, was the cat Nikolai's idea or yours? It's a cat,
sorry?
no? The cat in front of the issue.
Oh, no, this is all Nikolai. So you can actually
Okay.
give him credit for using cool emojis. So yeah, this was in my case what it took me to move application to native image. Granted, this is, pure Java. There is nothing tricky happening here, but still it was just a one-click basically action to move it to native image. So I think this is pretty cool, and let us know if you like the demos so far.
In your case, so it was almost out of the box, but is that the case in all the situations? Like the majority of the apps out there, they might be quite heavy. Wouldn't those require some special attention?
I'm glad you asked me that. I have this one scary slide that I like showing at conferences, and that is like an honest answer to how easy or hard it is to migrate applications to GraalVM native image. And I will walk you through the steps, and each step will be like complete way to migrate to native, going from the best case scenario to a scenario that requires a bit more work from your side. So the best possible case scenario is when a library is being developed with native image in mind, basically, and is from scratch friendly towards native image. So maybe it's doing a bit less reflection, maybe it's written in a bit more functional way. And if we see those libraries appearing more and more often, that are just native image friendly out of the box, and they use it, for example, as part of their announcement and kind of marketing when they say in the announcement, hey, and by the way, this library is GraalVM friendly. So this is the best possible scenario. Now, what happens if that is not the case? And for that, I need to take a very quick step back and explain what could be the issues with native compilation in the first place. So the way native image works is that it builds your application ahead of time, meaning the runtime hasn't happened yet. And it means that it doesn't have awareness of what will happen technically at runtime. So things like reflection, serialization, accessing resources, etc., not always, but in many cases will require a config from your side to tell exactly what will be happening at runtime. Now, how this can be resolved? So some of those calls, specifically around reflection, many of them already work in native image out of the box. So if you're doing something that is a bit more predictable, sensible, commonly used, we have built-in support for reflection for many cases. But then if that call that you're trying to make is not visible to native image, what you can do then? So the next possible best option is if you provide config to native image to explain, for example, hey, I want to access this field from this class reflectively at runtime. Please help me figure that out, or something more complicated. Now, what happens if that config needs to be provided? The best possible case scenario is when a library will provide this config within the library itself. So this config is provided in the form of JSON files, which tell native image exactly what will happen at runtime and to build an application that is aware of those things at runtime. I can actually show you an example. So I used to show this demo where I had an H2 database application that was, failing to build, but then I showed people how to fix it. But now I don't even need to do it anymore, because if you look at the actual source code of H2, they provide this reflect config file for native image. And now, I mean, this is still experimental support, but this means that now when you're building your application and it's using H2, native image will see this config and will include all this information in the build, and will build an application aware of all those possible calls. So this can actually technically work out of the box without any config needed from your side. You will not even notice it. Just as you will pull in H2, you will have this config available that makes things work. So this is the second. Yeah, go ahead.
So if I'm say I'm developing my own library or framework,
yeah,
I should create this kind of file if I want my library to be out of the box supported by native compilation. That's what I get.
Are already doing things that are not working, that are breaking, then yes, the best thing you can do is to include a config like this in your library. And that are more good news, actually. So this seems not so exciting to write JSON files, and we agree with you. So what we actually have in native image is so-called tracing agent. And that means that we have an agent that if you run your application with the agent attached to it on the JVM, and you are executing a relevant workload, so you are showing us what the application is supposed to be doing at runtime, the agent will take a look at all those calls in terms of reflection, serialization, resources, proxies, and it will output this config for you. So you don't even need to write it yourself. You can run with the agent, and it will produce this config, and then you will ship it with the library to make all those things possible and buildable with native image.
Okay, that sounds good. I mean, having some kind of a tool to generate this would save.
I mean, my engineers always ask me to say that this is not a silver bullet. Please make sure that the config is complete. It's a majority of work for you, but not necessarily all the work. So always ask me to be very careful about those things. But if you have good relevant workloads that you will run on the JVM, then you will have a good, pretty complete config. And from what I talked to maintainers of many libraries, they say that with this agent, they usually generate 95% of the config, and then just manually go through what is failing and add more stuff if needed.
So to see to see if I understood correctly, so the main problems are when reflection is broken, when I cannot introspect, when I use reflection, that's where we have issues, no, with the computer.
I mean, some reflection calls will work. So things like class for name, etc., they will work. Let me see if I have this one reflection demo here. No, I don't have it handy, But if you are doing things that are less predictable in terms of reflection, so accessing something, not specifying like the class name, but like trying to trick native image into not understanding what is happening. If you're doing something a bit more unpredictable, then yes, for native image, without seeing your app running, because we are still in this ahead of time, built-in world, there is no way to know what will
So
happen.
where you have some kind of logic, something like you read the class name from somewhere and then you do something, and then that's not predictable, no?
Class for name should be fine, I think, but yeah, you could do reflection in a way that will confuse native image. But I just don't want to scare users away, because lately, at least it's my feeling from the apps that I'm building and me talking to the users, that most of this have been solved. Because one thing is that you can ship config in the library itself, but also we realize that not all libraries are ready for this yet. And what we did, and that's the next step that you can take in this path towards native image. So let's say your library does not ship config, but there is more things that you can do. So we have created this reachability repo. And this is something we maintain together with the community. And that is a centralized kind of repository of config for all the popular libraries and frameworks and tools. But let's say your library does not ship config for native image. Maybe they're still working on it. Maybe they're not ready for it yet. So what we did is that we created a centralized space where users and maintainers and just other normal developers working with native image can contribute config for popular libraries. And this is also integrated with our Maven and Gradle plugins. And the way this works is if you are building a library if you're building an application that is using, I don't know, let's say I saw somewhere here, test containers, right? So some of it will work out of the box, but let's say if you are hitting something that needs config, for example, such as here, the way this will work is that our Maven plugin will go here and pull this config for you if you enable it, but also even without you realizing that. And these things will just work for you without you even having to pass any config or saying, hey, can you look up test containers config for me? So if you are using our Maven Gradle plugins, this will be pulled for you and the application will just build and run having this config available. That was the next step on this path towards native applications if your library doesn't support them. And now, I did skip one step, and that is if you are on a version of a framework that supports native image, such as, for example, Spring Boot, Quarkus, etc., they offer you also a way to generate those kind of config files and hints for native image programmatically. So you can, for example, say, hey, in this place in my code, there will be a reflection call, and I already can see that it's not working. Can you please flag it for reflection of a native image? So you just basically add one annotation saying something like reflective, and the framework will take care of those things for you, and it will generate this config for you as well.
So to conclude, you have plenty of options to somehow
yes, and I
solve all
hope
the
I haven't
problems.
scared your users away just yet. So I want to show one more cool page, and we can maybe finish this configuration topic. So
We have also a question from one
Go ahead.
of our followers. So does this tool make the file at build time or at runtime?
Sorry,
I
can
mean,
you
do you need to run the application to build that file with the configuration, or it's build time when you build the
so
application?
the config is being picked up at build time because
Build
it
time.
helps native image understand your application more and basically make more things visible to native image. Yeah. What I wanted to show is this page that we have on the website that is called Frameworks and Libraries Ready for Native Image. And this is a very, very long list of things that are continuously testing and integrating with native image and are known to be working with native image. This is maintained and contributed by our community. So all of those things will just work for you out of the box. And I think we can all agree that this is a very long list. So I'm showing this to make a point that if you're building, especially a new application right now in 2024, and you're using one of the frameworks and libraries from this very long list, things will just work for you out of the box. And it's my experience talking to users that lately things mostly just work. And whenever I get a question that is like, oh, but library X doesn't work, it's rather uncommon. So typically users talk to me about other things, but libraries lately, it's not an issue. So if you're building a new app now, then things will just work for you. So that's pretty cool. Do we have any more questions or comments yet?
Yes, someone is asking a very interesting question, actually. So I heard about GraalVM support for polyglot programming, but I'm not having any idea or use case. Can you detail us more about polyglot programming?
Sure. I wanted to actually show you, and I decided to move on because I thought we are like bad on time, but I definitely like that question. Let me show you. If you go here, we have this very cool application that is showcasing specifically the polyglot features. Let me Python, if I can type. Yeah, this one. Yeah, this one, GraalPy. So the reason I'm showing this is because I want to show you how easy it is to embed, and then I will tell exactly what could be the use cases. So this is my normal Java application. We will take a look at the source code in a second, but I just want you to show the POM.xml file. So to pull in all my polyglot capabilities, everything you need to do is this. You add this GraalVM polyglot dependency. This is the general overall dependency for all things polyglot programming in GraalVM. And as you can see, this is just a normal Maven dependency, so pretty easy to set up. And then because this app is specifically a Python application, I'm also pulling in my Python, again, as another Python dependency. And now that I did that, what I can do is I can go here to my application. And granted, this is fairly small application, but just to show you how this can work in practice, if I want to build something like that, all I need to do is I need to create a new context. And the context is this abstraction layer for that, what we call a guest language. So kind of separate it and define it separately from the Java app. So all I have to do is say, hey, this will be Python. And this is my actual Python code, or in a similar fashion, you can use a Python library. So this is pretty much everything that you need to do to.
But you need to have Python installed, no? I mean,
No. This will take care of everything for you. This is
okay.
our own Python. This is not your C Python. This is GraalPy. So this is our
Wow.
Python implementation. Yeah.
Oh, wow. And what languages, which other languages are supported?
So in this fashion, you can pull JavaScript, GraalPy, Ruby. We also have Java implemented this way as well. So you can technically embed Java into Java with GraalVM in a similar fashion. So you can have
Something
this
like Inception.
mode. You can do Ruby, and I think you can do WASM. And those should be the languages that you can put this way. But also, if you are specifically interested in polyglot programming, let me see if I can super quickly find that list. We have a very big list of, no, Truffle, Ruby, Truffle. Very big list of languages that both we support and our community supports. Let me just go here, Truffle. Where was this readme with the languages? Okay, I cannot find now, but in reality, there is way more languages that, for example, our community supports. It was just somewhere here, but I just cannot super quickly find. And the reason to do so is because, as you can imagine, in this way, if you can this easily embed a library from another ecosystem, it means that if there is some very specific library that is doing something that, let's imagine, you cannot find in Java, even though I think pretty much everything you can find in Java. But let's say there is something cool in Python that lets you produce cool charts or do data science, and maybe you just found specifically one Python library that you want to use. This will be a way to do it. And I think this is a very fairly easy way to embed them in Java application. So clearly all the Python cool stuff is one good use case, but another use case, and we see it a lot, is if you want, for example, to let your users execute some scripts, so user provided scripts or something on your platform, and you want to make sure that you can still run it on your Java runtime, and B, maybe you want to isolate that layer and you do not necessarily trust that those scripts that your user will execute. We see a lot of interest in JavaScript there because you can embed in a similar fashion GraalJS, and then you can isolate that context where those scripts are executed. And this can be both good for your users because you can extend this capabilities that your platform offers them with those scripting capabilities, but also you can have a more safe sandbox execution environment for those scripts because maybe you do not necessarily trust them that much. So you can do more crazy polyglot stuff with GraalVM. You can mix and match languages as much as you like. But I think this use case in Java applications is where we see a lot of interest in the community, and I think rightfully so.
Oh, that's fantastic. So I think the first thing I will try is evaluate some Java, that evaluates some Java, that evaluates some Java, that evaluates some Python. Can I do that?
Absolutely.
Okay.
Sounds insane, but that's the kind of thing that you can do with GraalVM. Okay, let me go back to the list of things that I want to talk about. And I think you and I wanted to do like 40 minutes. So let me see if I can prioritize what we see here. I wanted to say a few words about other open source community on GitHub. So I mentioned the GraalVM is also an open source project. We actually have a very big repo on GitHub. So this Oracle Graal is our main repository, and we just recently reached 20K stars on GitHub. So I just wanted to have a chance to mention that, but also to thank our community for being so supportive and, supporting us in this journey of building GraalVM. And I promised you more cool news. So one more of such cool news is that we recently saw there were like many posts on Twitter about this native Kafka broker. So now they have a new Docker image that lets you build, oh, stop, not here. Where is my Kafka stuff? Okay, maybe I close the tab. No, this one. So this is coming directly from the team who are working on this Docker Kafka image. And here are a performance chart of running Kafka brokers on the JVM versus native image. And I just bring this up because I want to be like very precise and that I'm repeating their numbers and not making things up. So they said in their measurements, and the reason why I wanted to go with native image is because they noticed that the startup time with native image got down to 130 milliseconds, which I think is pretty cool for a Kafka broker. And then another observation that they noticed, and I'm very happy that they did, is that there were no CPU spikes for GraalVM, because on the JVM, the execution is very dynamic. Many things could be happening. GC could be kicking in. There could be other things happening. But on native image, execution is way more stable because everything is compiled and optimized ahead of time. So you can expect very high performance from the beginning, but also very predictable performance over time. And they also use those cool PS record charts that I love. And the reason to read this, it kind of looks complicated because the chart moves with the number, so it adjusts to the scale. So for example, here, memory usage for native image is around 100 megs, and for the JVM, it's around 1 gig. But because the scale is different, it's a bit it's a bit hard to read. But the memory usage here effectively is 10x lower. And you can also see that the CPU usage is fairly stable. It's just the scale is very different. It's not the same scale as on the left. So that's very cool. Maybe you can give it a try and let us know how you like it. And
lots of people, so many projects using Kafka, they would benefit a lot from
absolutely.
this.
And I already saw many cool tweets saying that this will be amazing and very helpful. So I think so as well. And I think people will like it. And again, as I said, you and I both like Spring Boot a lot. All the frameworks are amazing, but you and I are always talking about Spring. So I wanted to mention one more thing. If I haven't closed that tab. Oh, okay. I think I might have. I wanted to share the numbers. I cannot find the tab now, but I wanted to share the numbers of from the Spring team. And they were talking about, they did this State of Spring survey when they asked many questions from their Spring users. And some of the numbers were how well do you know GraalVM? How are you using GraalVM at the moment? I don't have the tweet. I closed the tab, unfortunately. But I remember the numbers were around 11% of Spring users are already running on GraalVM native image. Then something like 30% are planning to do so, and 30% are planning to evaluate. So I like this a lot because people always ask me, who is running on GraalVM? Can you give me some examples? I wanted to give it a try, but I'm a bit hesitant because it's so new and revolutionary. I'm a bit afraid, but we can see that every year those numbers always grow, and this is very cool. And since you asked me about GraalJIT, I showed you numbers from Ionut, but there were also very cool numbers from, I believe, the lovely people at CERN, actually. And they did those benchmarking on Apache Spark workloads, trying to find what is the best optimal runtime to run Spark workloads. In their measurements, they measured a variety of OpenJDK and Oracle JDK distributions and also GraalVM. And in this configuration, so Oracle GraalVM Java version 17, they haven't benchmarked the latest versions, but they might benchmark 17. The execution time was, for example, 34 seconds for GraalVM JIT, as opposed to, let's say, OpenJDK 42 seconds. So I think this is a decent speed up from just switching to a different JDK. And also I can only imagine that they are running very high load workloads. And they're also talking that this is a very CPU bound kind of workload. So I can imagine how this is saving them a lot of time, but also a lot of CPU cycles as well.
Is there any reason I wouldn't decide to go with GraalVM?
I like that question because that's another one that I always get at conferences. And my answer is always use GraalVM. But the question is which part of GraalVM, right? So I mentioned GraalVM has like three big parts, three big components. And my answer is always use GraalVM, but just decide what you want for yourself. So if you want, an easy migration path, just basically replacing the JDK. And if you're looking for additional performance, then definitely GraalJIT is the way to go. Now, native image is very good if you want to have fast startup, very small packaging size, but also if you care about the resources usage, such as CPU, memory, etc., the native image will help you reduce all of those significantly compared to run on JVM. And then if you want to embed other languages, maybe you want to extend your application with libraries from other ecosystems, you can then do so by using GraalVM's embedding capabilities. And I think you set me up very nicely to summarize this talk. And I had a few more links that I wanted to show, but I can maybe just send you to them as links and we can
I can put them in the comment section and then pin them there.
Sounds perfect.
There is one more question. I think you might have already answered it, but I will repeat it just to be sure. So is there any solution yet to include classes inside Reflect.json without running the agent lib?
I mean, if that's your choice, you can certainly run the JSON file, write the JSON files yourself, right? It doesn't have to come from the agent. Technically, what you can do is you can just create a file and write it yourself. If for some reason running with the agent is not an option for you. So you can definitely do so manually, and we have instructions on the website how exactly that file should be structured, what you should include. And also in the upcoming release, we are making some changes to the way those files are written and structured and how you can use patterns in those files. So hopefully it gets easier. I hope I got the question right. You can definitely just create them manually if you know exactly what needs to happen, or if maybe there are very few calls and it's just easier for you to write them manually rather than using the agent.
Cool. And I think were all the questions, Alina. Thank you very much. It was an excellent talk, and I've learned so many things, and I'm pretty sure our audience also. Friends, thank you very much for being so many here with us. So we had plenty of people, questions, and I'm also looking forward for your questions in the comment section afterwards. If you still have concerns, or if you simply just want to ask us something else, or maybe you've just seen this afterwards and you didn't have the chance to ask your question, do follow us on Twitter or X or whatever the name is now, and LinkedIn at least, on social media, so you can find more news, and of course see you at different conferences next time. Thank you very much, everyone. Thank you, Alina, again.
Thank you so much for having me.
Okay, we are out. Thank you. That was really good.